doing some of that. Not that complicated, but some of it. Probably not doing that. Any questions? Brianna?
Yes.
Really, we last left off with box on ground, and the application that what a scale really measures when you stand on it is the normal force you apply to the scale, not actually the weight. And so we're ready for the next installment, box on ramp. All right, so the little hash marks that I'm making there are indicating, at least the way I've drawn it, should be indicating that the ramp is part of the ground. So I'm not treating the ramp as a separate object. We potentially will do that in a moment. But right now, the ramp is part of it. Oh, sorry, forgot to write the title. All right. We're doing force diagrams, for those who have forgotten. The first step, I draw the two objects. Now I recommend drawing the box in the same orientation as it is in the problem for drawing it. There are some people who will straighten the box out, which is not inherently wrong, but the people who straighten the box out tend to draw the direction of the forces off. So I do recommend doing it that way, but not required if you want to straighten it out. That's between you and your higher power. Put up our checklist. So are there any of these forces that we can immediately eliminate that we know are not part of this diagram?
See?
Why can we eliminate that?
There's nothing flowing in.
Okay. No rope or anything like that, so tension gone. Anything else we can get rid of?
W?
Why?
Because they're both like relatively the same size. Like one's not a lot bigger than the other.
We assume that the ramp is part of a planet, that there's a planet there. So, what does W stands for?
Wait.
Yeah, there's definitely weight there. If the ramp disappeared, the box would fall.
Oh,
And why can we get rid of O?
we don't care, it's not getting to us.
Yeah, I didn't mention any other problem, any other thing. There's no hand of God. There's no mysterious forces pushing on the box. Yeah, we can get rid of O. All right, so we are left with those three right there. This is the first time we've done friction. But let's hit the easy one first. Weight, as in W-E-I-G-H-T. What is the direction of the weight force acting on what object?
What is the direction? One more time? I'm sorry.
What is the direction of the weight acting on which object?
Right.
Weight acts to the right.
Oh, no.
Brianna, you said something?
The way it's acting down.
On.
From the box to the ramp.
Let's work on the wording. I think you would draw it correctly, but the way you said it seemed a little off.
The weight is acting down to the ramp.
Ideally, the wording would be, it's acting direction, you said down, on
Okay, on the ramp. Right?
the weight is not acting down on the ramp,
On the box.
on the box.
Okay.
The planet's pulling down on the box,
Okay, yeah.
so I'm gonna draw my arrow down on the box. It's towards the ramp, but
Okay.
I think if you can get into the mindset of it's acting on what object, that's the key there. Not towards what object, but on.
Okay,
what object.
okay, yeah, that makes sense.
All right, so if it's acting down on the box, what else must it be doing? There's gotta be another one.
Pushing against it,
All I heard was pushing.
like the weight of the ramp.
The weight is going up on the box?
Not up on the box. Okay, forces come in pairs, and each force in that pair acts on a different object.
So then the box's weight on the ramp. So the weight
Which way is that force acting on the ramp?
down.
Not down. The forces also in that pair have to act in opposite directions.
The box's weight is pushing on the ramp and the ramp is pushing on the box.
I think I'm having an issue with the word push. Weight doesn't really push, it's a pulling force. If I walked up on the table and I stepped off, I'm not being pushed towards the ground.
So the ramp is pulling the box?
That's what that is. If the ground is pulling the box, what is the box doing?
With the ground.
Yeah, so the ground is pulling down on the box is pulling up on the ground. Anywhere down here, it doesn't have to be right there at the ramp or just below that, there's an upward force acting on the ground. And that's one of the harder ones for beginners to visualize, is the fact that both forces are going both ways. The box is pulling up on the earth, but the box is so huge, the ground is so huge, the planet is so huge, we don't notice that. But physics does not play preferences. It doesn't go, well, the Earth's big, so it's special. No, it's just another object. I have two objects here. Now, the force of this weight is the weight of the box. So it's a very small force, huge mass. All right, so weight is done. I have only two objects. I got my force pair between them. Boom. Normal force. Which way is normal force acting on the box? This is a pushing force. And there are a couple of common mistakes people make at this point. If you look back at your notes about the direction, or sort of the direction of the normal force with respect to the objects, and then with respect to themselves, which way is the normal force acting on the box?
Perpendicular to the surface of contact.
Okay, therefore,
So,
Right.
you
Yes.
go that way? Where's the surfaces of contact?
on the ramp, box on the ramp.
The ramp.
Like that.
Yeah, so it'd be like,
Or like to the right or down to the
To
right.
the right?
Down that way?
Yeah.
Normal, what does normal mean? It's called a normal force for a reason. And it's not normal, it's not called normal because it's like everyone else.
two masses touching.
That's not, normal's a math term. I don't know when you first get exposed to it. But normal means perpendicular. So that's where it comes from. It's a perpendicular force. So if my surfaces of contact are like this, my normal forces will be perpendicular to that. So which way is it acting on the box?
This way, on this way? No?
That way? Is that what?
Yeah, that's what I'm guessing, yeah.
So that parallel to the surfaces?
Yeah.
normal, perpendicular.
Okay.
Just look for somebody to point in the right direction. So I saw that direction. Is that perpendicular to this?
No, I don't think so.
Was that?
I don't think so. Is that gonna be that way or that way? One of those ways.
No, it doesn't have to be just that way and that way.
Oh, well, no.
If I drew that line, let's see if I can draw that better. Which way is perpendicular? If I drew something perpendicular to that, okay, I saw a couple of hand gestures like that. Okay,
It would be like on straight on top.
so you going that way?
Yeah, so like there's a line and then like on top.
All right, it's got to, all right, surfaces of contact are going that
So
direction.
it'd be up
Yeah.
to the right.
There we go. Normal force is going that way.
Oh, okay.
Okay.
I get it, it's against the, okay, I get it.
It's perpendicular
To
to
the surface,
that.
yeah, okay.
And then the other one would be down that way. Now, no one said the most common mistake that people make, and I appreciate that. I don't know if in your head you just didn't say it. The most common mistake is always putting it in opposite direction of weight, and that is not the case. Even though in all the examples we've done so far, normal force was opposite direction of the weight, it is not always going to happen that way. And here's an example where weight is acting down on the box, but the normal force is acting at an angle. I have only two objects, and we have our normal force pair there. Two objects touching, we have our normal force done. We're left with friction, the new one. Friction opposes the relative direction of motion. So, which way, if the ramp were frictionless, just sort of imagine, ramp's frictionless, which way would the box move?
Down to the right.
All right. Friction says, not on my watch, I'm gonna try to stop that. So, acting on the box, it would be in the opposite direction.
Up into the left.
So friction is gonna be acting this way on the box. And they come in pairs. Where's the other friction force? Pointing that way,
Pointing down the ramp?
down the ramp, down on the ramp, that way. When they're talking about the force pairs, they're always in opposite directions, always acting on different objects. So if the ramp is causing drag on the box is causing drag on the ramp. Questions to hear? Let's make it more complicated. All right, it's box on ramp still, except this time the ramp is not attached to the ground. The ramp is a separate object. Now, if given a problem and you're trying to, and I'm asking you to do a force diagram, how do you know which objects are separate? I mean, do you want to, we could treat the top half of the box and the bottom half of the box as separate objects if we want to. On the test level problem, when I ask you to do the complex force diagram, I will break the objects up and I will separate the objects on the page so you don't have to figure out what are considered the same object or different objects. So I've got three objects here. I assume the ground is fixed. I have my box, I have my ramp, and I have the ground.
So this is called box on ramp, ramp not attached.
Yeah, or
Okay.
box on ramp on ground.
Box on ramp.
going through the exact same steps as we've done already. And there's no rope or anything pulling it like that, so tension's gone. There's no mysterious force that I threw into the problem. So we're getting rid of tension and the other, bless you. Let's start out with weight. It's sort of a combination of box on ramp and box on ground. All right, so. Weight is acting on what object? In which direction?
Weight is acting down on the box.
I am gonna use a subscript here because I do have more than one object besides the planet. So subscripts will be necessary. Where's the other part of that paragraph?
The box is pulling up on ground.
Weight does not require contact. Gravitational force does not require contact. All right, one down.
Weight is acting down on ramp.
That's it, covered all the objects, so weight is done. Normal force. Anywhere there is contact between two objects, there probably is going to be a normal force.
So the same as previous, so the perpendicular.
Yep. So nice that you have such faith in you that.
I know. So would it be the same for the ramp and the ground, perpendicular,
Which way is it going acting on the ramp?
horizontal? No,
Okay, what does normal mean?
Perpendicular.
Yep.
perpendicular.
So the contact is in which plane? It is the ramp, the ground touching like that? Like
No,
that? What?
horizontal,
Okay, so perpendicular would be perpendicular to that.
yes.
Yeah, so up and down. So it keeps one object from going through another. So I've got this normal force, some R there and normal force there. Those are the only, I got that touching pair and that touching pair, so normal force done. And now friction. Which way is friction acting on the box?
Against it, so this way.
Okay. It opposes the desired motion there, so F sub B. And the other part of that pair?
Down.
You say down, talking that way?
Yeah.
That's not opposite of that.
Like on the ramp.
Down and to the right.
Down and to the right, down the ramp.
Yeah.
Okay. Yeah, down by definition is,
I didn't say that.
if I take an object and drop it, it will go down. That is, down is defined by the gravitational pull. This is F sub B. But we do have another pair of frictions. Now, one thing, a normal force is required for there to be friction. So wherever I have a normal force pair, you need to ask yourself, is there going to be friction? Now, we've done examples what we did last week where we had normal force, we didn't have friction, but at least you have to ask yourself, is there friction between this and this? Indeed there is. So, I saw Brian nodding, that's why I was going with that. But if you two want to fight it out, doesn't sound like you're up for it.
Is the ramp moving with the ground?
I don't know if it's moving or not. But if it's not moving, it's because friction's holding it in place.
Oh, okay,
If
okay.
it is moving, well, friction's trying to stop it.
So
But-
friction, even if it's not moving?
Yes,
Okay,
yeah, unless I state that it's frictionless,
okay,
which I do occasionally on problems.
something.
All right, so in this particular case here, I've got the ramp, The question is, which way would it go? If I've got a ramp here and I put a mass on top of it, and the mass is coming down, which way will the ramp, if it goes anywhere, which way would it go? The ramp that's gonna
Oh, no.
dig into the ground?
No.
I will tell you that the ramp is gonna move parallel to the ground if it moves at all. It's either gonna move left or right.
So in this case, it would move that way, to the left.
Yeah, it wants to go that way. As this thing wants to fall, but the ramp is stopping it. So those box is pushing on it that way. So this wants to go squirting out in that direction. So which means that the friction is acting which way on the ramp from the ground?
That to the right of it.
Okay, so I got friction acting this way on the ramp, and then on the ground.
This way.
Oh, that was badly done. And another one. Done. Questions to hear? I don't think on that one. I have two boxes, I will label that one A and B. We're now introducing a rope. I do need to give some clarification